Okay, 7.5. We're going to be talking about trapezoids and kites. So we're still talking about polygons, but here we're talking about trapezoids and kites. We're moving away from parallelograms. Okay, this is the last section of chapter 7. This is it. I'm going to start down in our definitions again. Sometimes it is useful to start down here so we get a sense of what we need to be talking about. And I'm going to write what the book says here. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay. Those parallel sides, these parallel sides are the bases. Okay, so if I had a trapezoid, doesn't matter. Let's say I had something like this. Okay, and these sides are parallel. Those are my bases. The base angles are two consecutive angles whose common side is the base. Okay, so back to my trapezoid. These angles right here, those are my base angles. It makes sense because they both share the base. The legs are the non-parallel sides of a trapezoid. An isosceles trapezoid, that's what we're going to be focusing with today. If the legs of the trapezoids are congruent, so if the legs, it's an isosceles trapezoid, so we're obviously talking about a trapezoid. If the legs of that trapezoid are congruent, then the trapezoid is an isosceles. Still have trouble with that word, isosceles. Okay. The mid segment of a trapezoid, that connects the midpoints of the legs. Okay. So back to our trapezoid up here. Let's say our midpoint is here and here of those legs. This is the midpoint segment, okay, of a trapezoid. I'm going to erase. I'm going to scroll down here to kite. Okay, a kite is a quadrilateral that has two pairs of consecutive congruent sides. But the opposite sides are not congruent. Okay. So a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. And you guys should know what a kite looks like. Let's scroll up here. Let's go up to the top. We are going to go to GeoGebra. We're going to construct a trapezoid whose base angles are congruent. Okay, and it says explain the process. I'll be explaining it. And then we're going to be asked, is the trapezoid isosceles? Okay, so I'm going to start with my base. I'm just going to start with a segment. There's a segment, I think. Yep, there we go. Okay, I need a parallel line to this. Okay, so if I scroll up and drag that point somewhere, there we go. Okay. Again, I'm just constructing this segment, or this shape here. I'm going to need a point somewhere around there. I'm not sure where yet. Okay. Now, it asks, I need the base angles to be congruent. So I need my base angles. Well, remember, base is this, so I need these two angles to be congruent. Okay, so I drew my segment here. That might help with that visual. There's my trapezoid. But I need those base angles congruent. So how do I do that? I need to go to my angle measure. Okay, that angle is 64. What's B? It might be close. 61. Okay, so I need to make a little bit of an adjustment here. I need to, I need to move point D. To 64. There we go. Okay? Now, back to our problem. It said, is the trapezoid isosceles? Well, what does a trapezoid mean if it's isosceles? It means its legs are congruent, right? It means those two sides are congruent. Let's find out. Let's find the distance. Distance to, there it is. Distance to there is 3. That distance is 3. There we go. That is an isosceles trapezoid. It says repeats for several other trapezoids. Write a conjecture. Well, based on what we just did, what can we always say about this process? We can say that if the base angles of a trapezoid are congruent, then it is isosceles. Okay, so if the base angles are congruent in the trapezoid, then we know that it is an isosceles trapezoid. Next problem. It says construct a kite. Okay, remember, a kite has opposite sides or consecutive sides congruent, but the opposite sides of the kite are not congruent. Okay, so something like this. And then we want to measure the angles. Okay, well, I kind of already constructed a kite for us. Okay, this process takes a little longer because with GeoGebra it's hard to be exact all the time. But then it said measure the angles. So we're going to measure each angle here. And there's B. There's D. There's C. There's A. Okay. What do you notice? First thing that jumps out to my mind is we have a pair of congruent angles. Right? 117. 77 and 50. There's really nothing significant about those two angles, even if you added them up. Right? You get 127. So nothing too special there. Let's see, what does the question ask us? Measure the angles, what do you observe? Well, talk about it. Write a conjecture. What conjecture can we come up with? Well, we can say that if it is a kite, then a kite has exactly one pair of opposite congruent angles. The kite has exactly one pair of congruent opposite angles. Okay, moving on. What are some properties of trapezoids and kites? We've talked about them all. Is the trapezoid on the right isosceles? Let's go to number 4 and talk about it. Is this trapezoid on the right isosceles? Yes, it is, because it has congruent base angles. Yes. Congruent base angles means that its legs are congruent. Okay? That is a isosceles trapezoid. Number 5. Number 5 says a quadrilateral has angle measures of 70 degrees, 110, and 110. Is a quadrilateral a kite? Explain. No. No, right? No. Why? Because a kite has exactly one pair of opposite congruent angles. Not two. Not two like it says in the question. It has exactly one pair of opposite congruent angles. We already did the notes. Some things we're looking at here. Isosceles trapezoid base angles. Okay? We talked about that a lot in the first part. Converse. A trapezoid is isosceles if and only if its diagonals are congruent. So the diagonals of an isosceles trapezoid are congruent. And that means that these diagonals here, BD is congruent to AC. If it is an isosceles trapezoid. The mid-segment theorem. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of its lengths of the bases. Okay? To find MN, to find the length, we use this formula right here. We take the distance of AB, okay, plus the distance of CD, and multiply it by 1/2 or divide it by 2. And that's how we find the mid-segment. We're going to be using that. Something to know. Something good to know there. The kite diagonal theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay? And then we talked about the opposite angles. Okay. Some extra practice here. We have, we want to write a quadrilateral with the vertices at these points. What I notice is that we're going up and to the left. So I'm going to make kind of a graph that looks like this. Okay, where these are my x's, these are my y's. Okay, but I'm working on the negative side. It says at 0, 3, there's point Q. That's a big Q. My apologies. R is at 0, 6. Right there, that is R. S is at negative 6, 0. That's S. And T is at negative 3, 0. I'll rewrite that other side there. Okay. It says decide whether the trapezoid is isosceles. Okay, what do we need to prove in order for those two, or for this trapezoid to be isosceles? We either need to prove that these angles are congruent, or that each side or each leg is congruent. I think the legs are easier to find. The distance from S to T. ST is equal to 3, right? And RQ is equal to 3. Okay, so this is an isosceles for sure. I'm just going to write a little check mark next to my isosceles here. It is an isosceles trapezoid. Then we need to find the length of the mid-segment of the trapezoid. Okay, that's going to be some work here. One thing I forgot to do. I have to show that it is a trapezoid. Okay, how do I show that it's a trapezoid? I need opposite parallel sides. Our opposite parallel sides look to be this one and this one. And how do I show that two sides are parallel? Talk about the slope, right? The slope. Well, the slope of S and R can be found with this formula, y2 minus y1 over x2 minus x1. Okay, so our y2 is 0 and our y1 is 6, so 0 minus 6 over x2 minus x1, which is negative 6 minus 0. That equals negative 6 over negative 6, or 1. Okay? Now we need to find the slope of TQ. Okay, so I'm going to take 0 minus 3 over negative 3 minus 0. And I will get the same thing, I'll get 1. So that is a trapezoid. We know that the opposite sides are parallel. Okay, we know it's an isosceles trapezoid. Now we have to find the mid-segment of that trapezoid. We have to find the length. So to find the length of the mid-segment, remember, is 1/2 of our base, so RS plus TQ. And so I need to find the lengths of RS and TQ. How do I find the lengths? That's right, I have to use the distance formula. So I'm going to go up here. RS is equal to, it's this big long square root. RS, R, and S. Remember, it's x2 minus x1 squared. So negative 6 minus 0 is negative 6 squared plus 0 minus 6, which is 6 squared. So we're going to get the square root of 72, which is, I need my phone, it's about 8.5, I think. Yep, 8.5. So about 8.5. Perfect. You could also write this. You could write the square root of 9 times the square root of 8 is 72. I'm actually going to keep it this way. Actually, sorry. You could say it's the square root of 36 times the square root of 2. And the square root of 36 is 6. The square root of 2 is left the same. Okay, I just broke the square root of 72 into simplest form. 6 square root of 2. Now we need to find TQ. So T and Q. So we're going to have the square root, so TQ, equals this big long square root of 0 minus 3, which is negative 3 squared, plus 3 minus, or negative 3 minus 0, which is negative 3. Square it. Okay, and we're going to get square root of 9 plus 9, or the square root of 18. Okay, we can simplify this into the square root of 9 times the square root of 2, which is equal to 3 square root of 2. To our length of our mid segment. We have 6 square root of 2 plus 3 square root of 2. Multiply that by 1/2. These are 6 square root of 2 and 3 square root of 2. Those are like terms. We can add those together. We can say that 6 square root of 2 plus 3 square root of 2 is 9 square root of 2. We have to multiply that by 1/2. And you should get 4.5 square root of 2. A lot of steps there. A lot of steps to find the mid segment. But we can do it. Okay, moving on. Exercises 2 and 3, we want to find the measure of angle K and the measure of angle L. Notice this is a trapezoid. We have 2 parallel sides. It looks to be isosceles because we have 2 congruent sides here. So the measure of angle L is 23. The measure of angle K, right there, K. That might be a little harder to find. We know that it's a trapezoid. We know that it's a quadrilateral. The interior angles of a quadrilateral add up to 360. Another thing we know is that K and L, they're congruent because it's an isosceles trapezoid. Those are congruent angles. Okay, so what we have to do is we have to add 23 plus 23 plus, well, K and L are the same measure, so I'm going to say 2x equals 360. I said 2x because we have 2 angles that are missing, and they're the same angle, x. 46 plus 2x equals 360. Subtract 46, I should get 2x is equal to 314. And x is going to equal 157. Okay, so I know that the measurement angle K equals 157. Number 3, K and L. Okay, what shape do we have here? We don't have a trapezoid. We have a kite. Okay, we have congruent sides there. We have congruent sides there. Well, what do you know about a kite? It has 1 pair of congruent angles. Right? So K and L, they're the same measure. We have to find these a lot similar to how we found K in the last one. Okay, we have to add them up. and set them equal to 360. So we know that we have 130 plus, we know that this is 90, plus, I'm going to say 2x equals 360. And again, we have two of the same angles. 130 plus 90 is 220, plus 2x equals 360. Subtract, we get 2x is equal to 140, and then x is equal to 70. So we know that measure of angle L and K equals 70. Number 4, find CD. Okay, well, we have a trapezoid. It looks to be the mid-segment. Okay, so how do we find the mid-segment? That's 1/2 our parallel side. So 1/2 times 12 plus 36. 12 plus 36 is 48, so we'll have 1/2 of 48, which is what? 24. CD on this one is a little different. Okay, we already have the mid-segment. We have 1.8. Well, 1.8 equals 1/2 of 0.6 plus CD. Okay, CD is just one variable. We'll get, if we distribute, we have 1.8 equals 1.5, or sorry, 1/2 of 0.6. Does it get bigger or smaller? You get 0.3. Okay, plus 1/2 CD. Okay. Subtract 1.8 minus 0.3. We'll get 1.5 equals 1/2 CD. How do we divide by a fraction? We multiply by the reciprocal, right? So we're going to be multiplying by 2. That'll cancel out our fractions. Multiply by 2. We should get 3. Okay, just manipulating equations. That's all we're doing here. Number 6. Find the value of x. Okay, so we have a big equation, which is fine. We know that 3x minus 2 equals 1/2 of x plus 11 plus 3x plus 3. Okay, always do what's inside the parentheses first. Okay, so inside our big parentheses here, we can multiply or add like terms. We have x and 3x, that's 4x. So we're going to get 1/2 times 4x. We have 11 and 30, or 11 and 3, which is 14. And that's going to be equal to 3x minus 2. Distribute the 1/2. Okay, we'll get 2x plus 7. So I'm going to write it over here. We have 3x minus 2 on that side. Equals 2x plus 7. Okay, from here it's just solving. If we subtract the 2x and we add the 2, we'll get x is equal to 9. Okay, final problem. Let's see if I can do it under a half hour. Probably not. We have 9 and 10x minus 1. These two sides, we may not have mentioned it, but those diagonals are congruent, okay? They're congruent. We know that 9 is equal to 10, or 1 over 10x minus 1. If I add 1, I get 10 is equal to 1 over 10x. If I multiply by the reciprocal, I'll get x is equal to 100. Ah, just over a half hour.